Right, we're back after a couple review days and no videos. Today we're going to sort of keep going down the iteration um, rabbit hole, but we're also going to learn a little bit of web scraping data using the package rvest. So the data we're going to use here is from the Center for Snow and Avalanche Studies, and the data is over here in the archived data section. And what I want to eventually do is download these three sites. So we have the Swamp Angel study plot. There's basically three study plots where they're measuring really detailed information about snow and precip and other things. And you can read this paper to sort of learn more. But basically, there's a study plot called Swamp Angel. There's a study plot called Centerbeck, and a study plot called Putney. Now, obviously, I could go in here and click on these things and download them as CSVs and then move them to a file, and we could start from there. But I wanted to show you how to do this using HTML parsing, so R can actually read HTML files and find this data programmatically. And this would be useful if you didn't have just 3 things to download, but maybe like 50. So I've started a GitHub called San Juan Snow that you should go to find this code. And we're getting into areas of code that I don't do all that often, so I was practicing ahead, so I've written some of the code already. But basically, you need to load this package called rvest, and we're going to use tidyverse, lubridate, and then this package called readxl, and we actually don't need magritter, so we can take that out. Okay, so now we just get the site URL from this website, so that's just up here. And we just say, hey, this is the site URL. And then now we're going to start using the rvest package. So basically, what we want to say is Webpage, and we're going to use this command called read HTML. And we're just going to read the HTML that is at the URL. So we're just reading this website. And, oh, I need to load the packages. So I'll run this again. And now we get this thing just called Webpage. And if you look into Webpage, it doesn't really have things that are really understandable to you, like human readable. This is basically an XML document, and that's how web pages are rendered. So if we want to extract specific things from it, we need to find HTML nodes. And so if we want to say, like, maybe look at the tables that are stored in this web page, we would say web page HTML nodes, and then we would want something with the attribute just called table. That's what anything on this website is going to be that we're interested in is going to be called a table. And you can sort of verify that this is the proper object that you think it is by going right-clicking on the sort of object of interest. In this case, it's this whole table, and then we can do inspect element. And you'll see we'll go into this, we're zoomed in all the way to here, and so this is just how the web page is rendering this. But if you scroll up, we'll find a table column up there, but then we'll find that this is our table that we're looking at. So this whole object is called the table, and in the bottom left where my mouse is, you can see that the attribute of that is called table. So that's great, and then you can just sort of look through it and see different ways that the table is organized. I can already tell that reading this table in is probably not going to be our likely approach because we have it has uneven spacing throughout, and R is going to struggle with that. But let's go ahead and extract the table nodes, and then we'll just say what is tables now. Okay, well, table is a node set of 4, and there's just 4 different objects here. And let's see if we can slice out the third one, which I happen to know from trying is our table of interest, which has this data. We want to get this all 24-hour data. So let's see if we can slice in an XML. I figured not. We can't. So this is where we actually need magritter. We'll do extract. We're going to extract the third table. And now we have this thing called table, and it still is not really interpreting it, and that's because we need to tell R that we want to read it as a table. So we're just saying now, hey, this is a table. And then we're gonna this error is important, and it's because it has an inconsistent number of columns, and you can kind of tell that just by the way it's organized up here. It's not going to be super readable to R. So we'll go ahead and say fill equals true. Okay, and then we have this information in here, but it's not really the way we want to look at it because the key that we need is the hyperlink to the data set. So this approach is sort of not going to work. So let's go ahead and do a different approach where we're going to get links. So now we still have Webpage. And in this case, we don't want the nodes that are tables. We want the nodes that are references, which is, if you've ever coded in HTML, A indicates that you're going to have a link to something else. So basically, when we look at this, when I click here, this is a hyperlink to something else, which is this address, which has this address, which is the CSV. And that's the address we want to extract. So let's go ahead and look at links. Okay, so we get links. So there's 252 links on this web page. That's far too many. We only want 3. So let's go back to the web page and sort of look at some words that might be helpful. Okay, so this is all 24-hour data. So I'm going to look using pattern matching for this pattern that says 24-hour. I don't think it's repeated anywhere else. So we're going to go ahead and use that approach. So we'll minimize this web page. And now we're going to use some sort of what's called regular expression matching or pattern matching, and we're going to use this command called Grapple. So I'm going to take the object before, which I'm going to indicate with a dot. So that's the list of 252 links. And I'm going to subset it using base R syntax, which is these curly bracket, or sorry, these square brackets. And I'm going to use this command called Grapple. And what Grapple does, and you can see this here, is it takes a pattern. So in this case, we're going to make that pattern 24 hours, and then it checks a vector for any of those where that pattern occurs. So Grapple 24-hour, that's the pattern we want to find. It's inside of the dot, and now we'll just get a link list of 3. Oh, it's a 4, and that makes sense because it's also wanting to download the stream gauge data. So that's fine. We can go ahead and download all of those. So we'll keep that stream gauge data and download it. But you'll notice it's not in a form that is sort of computer readable yet. It still is in it has like HTML text. And all we really want is just this part that has the full CSV name. So to extract that, we just say HTML attribute, and we just want the href. So again, this is href equals, and that's all we want to extract. And now when we get links, we get the correct full link name right here. Okay, so now we have something that says links, and it's the exact links to the site, the data we want to download. So we'll make a new chunk. This is extract CSV links from web page. This is not something I expect you to fully sort of understand right away. I just want you to know that you can do this kind of thing, and it's particularly useful when you have more than 3 or 4 observations. So now we're going to download the data, and this should look familiar. We're going to use some looping to download this data. First, I'm going to go over into my folder here, and I'm going to make a new one, a new folder inside of my repository just called data, and we are going to use this command download file. So let's go ahead and say let's explore how to download the file using download. So this is just a command, and it's going to download a file using a URL, and then need to tell it where to go. Okay, so when I tell it where to go, I obviously want to name it something useful, so I probably want to go ahead and get this name at the very end of this long list, SASP 24 hours. So the SASP is going to be the snow angel plot, snow angel snow plot. So let's go ahead and extract that from the string, and again, we're going to use some pattern matching tricks. So here, what I'm going to do is I'm deciding what I'm going to do. All right, it took me a second to figure out how I want to do this, but we're just going to use a function called string split fixed. So if we look at string split fixed, actually it's already up in the column over here. But basically we feed it a string, which is going to be this thing, and then we feed it a pattern, which we're going to split on a backslash. So we have 1, 2, 3, 4, 5, 6, 7 backslashes. So let's go ahead and say splits. And we're going to do string split fixed. The string is links. The pattern is I keep calling that a backslash. It's a forward slash. Is a forward slash. And we have 7 of them. So let's see if that did what we wanted. Okay, I miscounted, so we want 8 so that this 09 isn't there, so we'll just get this last bit. We'll go ahead and call it 8. And now we get this, the last section is this ASP 24 hours, and so we're going to go ahead and extract just that, so we'll just call it names, rather dataset, and that'll be splits. And it'll just be the 8th column. So that's what we're doing here. We're just grabbing that 8th column, which has the name. And then I'm actually going to pipe that forward and use another pattern matching trick to get rid of that .csv. So here we're going to sub the pattern, which is .csv. And you'll notice here, string split fixed is tidyverse, and you can see that the vector comes first and then the pattern. But this gsub is a base R. So that's why the pattern comes first, just a sort of syntactical note. The replacement here, we're just going to have it be empty, and we're just going to replace the this character in this object. So we're just going to put a dot. So now when we look at data set, it's just going to be that. If I break that pipe before I sub, it'll just look like this with the .csv, and if I put the pipe back there, it's going to replace that CSV with nothing. And now we have some nice names. Okay, so now that we have the names, we can save these files properly. You know what? We actually want the CSV, I just realized, because we're going to make another one called file names. And we're just going to paste the folder data onto the dataset name. And that's just going to be dataset. And then that's going to leave us with this thing called file names. Oh, I need to rerun this. .csv. And now if we go back to looking at download file, we'll have the URL and the destination file. And we can do this, we can sort of loop through this. So what we'll do is we will, I'll do this probably 2 ways just to show you how to do it 2 different ways. So we'll do for I and 1 to the number length of this thing called file names. And we never change the order here. So when we download the file, it's going to be links, and then we're going to subset it to be the first one, link sub I, and the dest file equals file names sub I. So, you know, I made this loop first, but maybe we should test it. So I'll do I equals 1, and we'll just see if we can download the data. Okay, it looks like it's downloading it. And then let's go into our data, and there it is. And just to avoid sort of having conflicts with overwriting, I'm going to go ahead and delete this. And then I will run this code. And while that's running, I'm going to just say in a for loop. So you can see how if you could sort of use these tricks, and this was 60 files, then it would be worth it to do this programmatically rather than pointing and clicking your way through. Okay, so now we have the files downloaded. Let's go ahead and download them again in a different way. I'll try to show you how to do it in a map. So I'm just going to delete those files again. Sorry for hitting your server. Snow and avalanche studies. Okay, so we have everything we need still. We're just going to do a map, and we're going to map over, it's a map 2 actually. So map 2, if you want to look at it, it allows you to feed it both an X and a Y, and here we need to feed it both the links and the file names. So we'll do map 2, and we're going to say links and then we're going to say file names, and then we'll do download.file. And let's see if that works. Probably, okay, it does. So again, this is just a more compressed way and a way to avoid a for loop, but it functionally does the exact same thing. If we go back to our file, our data, then it re-downloaded. So we'll leave this one intact since I'm trying to map version of the same. So just to reiterate, this is sort of the end result of this call is identical to the end result of this call. And I can't have eval equals false. I'm just going to comment this out and take away the eval equals false. So if you want to run the for loop version, you just need to comment that back in. Okay, so now we have the local data. And let's read it in. Read in the data. My phone's ringing. Apologies. Read in data. So now we have 4 files here, but we only want 3 of them. And we know that when we go back up to the website, I was looking how to split, and we go to the archival data. We have these Swamp Angel study plot, Senator Beck study plot, and Putney study plot, and then we have Senator Beck stream gauge. And this one ends with an SG. None of the other ones have the SG pattern in them. So what we can do, if we just want to read in the snow data, instead of the stream gauge data, what we can do is say snow files, and that is going to equal the file names. But here we're going to, again, subset the file names based on some pattern matching. So we'll do a dot, which represents file names. And then we're going to say, I only want the ones that do not have. So we'll go back and put this exclamation point, and we'll say that do not have the pattern SG underscore 24. And so that's the pattern that we're matching on. And we're doing it with this file name. So I'm just going to put another dot. And that should give us just 3 files. And it does. So that's the 3 files we want. Now we want to read in those files. So again, I'm going to show you how to do this with a loop. I don't think you should do it this way, but I think many of you understand it easier this way. So let's say snow data. We'll say for I in snow file 1 to length snow files. And 1 to length snow files is just going to make a little vector that's 1, 2, 3. We are then going to say empty data. So this is just a list. Oops. And then we're going to go empty data. The first one on that is going to be read CSV snow files I. Yeah, so I equals 4 for now. We need it to equal 1 just to test this. So I'm going to run just that line. Okay, we read that in. We have this thing called empty data that's filled with something. So let's just go ahead and loop that over. And then to sort of map all those into just one data set, we'll go ahead and say full snow data. And we're going to go ahead and do what's called a map again. And this time we're going to use empty data. And we're just going to what's called row bind it, R bind. So now we have this thing called full snow data. Ooh, that didn't work. Yeah, let's try bind rows. Oh, I don't know why I'm putting that in. I just need to unquote this, I think. Bind rows and R binds are generally the same. Huh, this is still not working. Okay, I'll try a different. This is a base R version of the same thing. We're going to do call. We're going to repeat we're going to rbind the data, and then we're going to do it over empty data. Okay, that's not working. Okay, so that's not working, but that's okay. What it's telling us is that it can't bind these together because the number of the columns doesn't match. And this sort of gets at the sort of problem of the way I've introduced this exercise, where we didn't really check out the data before we tried to bind them all together. I was acting under the assumption that they were all sort of the same, and again, I don't know this data very well. So let's go ahead and do a structure on our empty data list, and that should give us an indication of why these things aren't working. So it's just going to print every one of those data frames, sort of the structure of it. And right away, we see that the last one, the third item in that list, has 5,000 observations of 25 variables. And if we look through this, it's mostly wind speed and nothing about snow depth. And then if we scroll up to the next one, we see that it has 48 variables. And so that's why they can't bind together, because they're not the same kind of data. And the very first one, I think, has something like 52. So in order to sort of programmatically read all this data in, we need to change some of the assumptions we made earlier. And that's a great time to go back to this web page, and they have these metadata files, which would tell you more about each study site. And if you look through here, you'll see that only the first two of these have snow depth data, which was what I wanted to sort of show. So actually what we're going to do again is we're going to drop this PTSP, so we can just go back up to our snow files, and we can do another filter, and we'll just remove PTSP. So we're just copying that sort of same idea, and now snow files should become 2 sites. Oh, that didn't work. Oh, I messed up the Grapple. And now we'll look at snow files. Okay, and then we have just 2. And those 2, I think, both have something called, if we look through the data again, they have something called snow height, which is sort of the simplest thing for us non-snow researchers to understand. Okay, and so now we just are going to have only 2 things that we're looping through, but the idea is the same for 2 or 50. And we still have a problem, though, because this second one has only 48 columns, and the first one has 52. And so that's sort of going to give us problems, but that's okay. We'll still read it in this way. And what we're going to do is make a data set of the names of each of these column names. So names 1. We'll go with empty data. I'm sort of just showing you a bunch of different ways to read this out, because for a lot of you on your projects, I've seen you try to read in lots and lots of data sets, and this is just sort of how you think about combining them. Is you got to make them look the same, and then you also want to make them each have an identifier. So we'll do names, empty data. Actually, I'm going to do something completely different. Let's go back up and look at the columns that are in here, and let's just immediately simplify this a lot. So we're going to have a read CSV, and then we're going to immediately select only shared columns that we are interested in. So we definitely want year. We definitely want day of year. And it looks like hour is repeated, and that's because we downloaded just the 24-hour. So we only have daily data, basically. And all we're going to look at just for this brief exercise is going to be the snow height. So we'll go snow height meters. And so now we'll get this empty data. If we try to do snow data full, and we're going to use that do call thing again. Do call is like a map. It's going to repeat this for the number of things in the list, which is only 2, but we're going to have empty data, which is no longer empty. I think I didn't rerun that. Now it should work. Okay, so now we have this thing called snow data full. If we look at the snow data full as a summary, we see that we have year, day of year, snow height in meters. And we'll use some of the same ideas here. I'm going to comment out this for loop so we don't do it twice. I'm going to comment this out as well because we'll do it with the map function. We don't need that. And I'm going to comment that. So now we just have these snow files, and we're going to make in our snow reader. We're going to make a function that reads the data. So it's going to be it's going to be function files. So it's going to read in files, and it's going to say just df. It's going to be read CSV files. I'm just going to call it file, actually. And then it's going to do the same select that we did up there. So select year, day of year, snow, height, m. Okay, so now we have this thing that does the same thing as the loop, and we can say snow data full, and here we'll do map DFR, and what DFR means is we're mapping over a data frame and we're going to row bind them. So we're going to map over that list, which is sorry, not that list. It's just a vector of two files. So we'll just say snow files, and then we're going to use our snow reader. And then now if we look at summary snow data full, it's identical to the previous one. And here you're going to start to maybe see a problem is we did not keep track of the site names. So we're going to have to go back into our function and see if we can split out the file name from it. So we have this thing called snow files, and we can just use our knowledge of gsub and string split to keep just this SASP name. So we'll go ahead in here and say name, and that's going to equal, I'll do string split fixed on file, and I'll keep the second column because we're going to do just this right here. We're going to keep just this file, and then the pattern is a /. We're keeping just the second half, and then we are going to sub out 24-hour. We're going to actually sub out this whole string underscore 24-hour.csv. The replacement's going to be nothing, and the vector is just what came before. And then we're going to mutate this data by giving it a name, which is going to be site equals name. And now when we read our snow reader, snow data full. Ooh. Okay, so I made a mistake. So let's say snow files. Let's say file. This is just, now I'm just trying to debug this to see how that mistake was made. So I just want to grab the first one. So file is just snow angel. Let's see if that works. Argument in, oh, I didn't give it a, yeah. I should have read that error simpler. So let's see if it works now. Okay, it does. So the function should work. And it does. And now let's look at summary, snow data full. Great. And basically now we finally can just sort of plot some of the data. So we'll go snow yearly, and we'll do snow data full. We'll group by year, and we'll summarize. We'll just do mean height, mean of snow, height, m. We'll remove some, if there's NAs, we'll just let it remove them. And then let's go ahead and plot that. Oh, I can't just group by year though, I need to group by site and year. So we'll do snow yearly aesthetics, x equals year, y equals mean height, color equals site, gem point, and we'll just go So that's the mean snow height at these two different sites. So it looks like in general, I forget what, not Snow Angel one is, Senator Beck is lower in snow depth except for 1 year where it was higher. Okay, that's it for today. I just want to show you some web scraping and some more iterating on sort of local files.